So you received a formative or a practice quiz in class either yesterday or this morning, and I just want to take a little bit of time to kind of go through the answers for it. So the first one, I looked at C2H6 plus O2, and I made the connection that there's a hydrocarbon, so the C2H6, and the O2. So that tells me that this is going to be a combustion reaction. So I'm just going to put a C there. And the way I've been labeling them is a CX, HY, plus O2 will always react to form CO2 and H2O. So there's really not a lot I have to do here. There's really no charges to check and crisscross down. So I'm just going to copy down CO2 for my products and H2O for my products. And all that's left to do now is to simply balance. So we'll go ahead and balance this. And in this one, let's see, I have carbon and I have hydrogen and I have oxygen. And I see that on my reactant side, I have 2 carbons, 6 hydrogens, and 2 oxygens. And on my product side, I have 1 carbon, 2 plus 1 is 3 oxygens, and 2 hydrogens. So in an effort to make my carbons balance, I'm going to put a coefficient of 2 here, which will give me 2 carbons, but it's going to give me 4 hydrogens and 1 hydrogen. So I'm now going to have 5. I want to balance my hydrogens. And in order to do that, I'm going to put a coefficient of 3 here, which will give me 6 hydrogens. But it's also going to give me 4 plus 3, which is 7 oxygens. So when I want to balance the oxygens, I'm going to divide 7 by 2 and find out that it's 3.5. So I'm going to put a 3.5 here. Now, the next thing I have to do is I can't leave it like that. So I'm going to double all of the coefficients here, multiply them by 2. So I'm going to get a 2, a 7, a 4, and a 6. And so that will balance the first one. And again, that's a combustion reaction. In my second one, I see that I have I have a compound, right? AY. And so that tells me that that's going to be a decomposition reaction. And the decomposition reaction breaks apart into individual elements A and Y. So I'm going to kind of fill that in. And so now what I'm going to do is I'm going to put magnesium here, and I'm going to put nitrogen here. And at the top of the periodic, at the top of this quiz, I'm going to write Br2, I2, N2. Oh, geez, what happened there? N2, Cl2, H2, O2, F2. And I'm going to use that to test whether or not there is a subscript after magnesium. So if magnesium appears anywhere in this list right here, it would get a 2. And it doesn't, so I'm going to leave it as it is. Nitrogen is right here, so that one is going to get a 2. And then all that's left to do here is balance, right? So I have magnesium and I have nitrogen. And on my reactant side, there's 3 magnesiums and 2 nitrogens. And on the product side, there's 1 magnesium and there's 2 nitrogens. And as it's written right now, it looks like the nitrogens are balanced, so I'm going to leave those alone. And my magnesiums are not balanced, so I'm going to put a coefficient of 3 here, which gives me 3 magnesiums, and then it looks like everybody is balanced. If you got this earlier in the day, you would have seen that there was a 2 here, and you should cross it out because there should not be a 2 there. It was our mistake. But what I do see is that I have 1 element and 1 compound as reactants. And so that tells me that this is going to be a single replacement reaction, which means that in this case, what I really have to focus in on is what this element is here. Is it a metal or is it a non-metal? And in this instance, it's a non-metal. So that tells me that like replaces like, or non-metals replace non-metals. So the other non-metal is Br. So that's what I'm going to be actually replacing. So I'm going to get rid of that, the highlighting there, and I'm going to say that I have an X reacting with a Y, and this time the Y is going to be replaced by the X. So on my product side, I would have A, X, and Y. And so that's what we're going to do. We are going to set that up. So I'm going to take silver, which is my A, it's my metal, and I'm going to put Cl here. And then I'm going to put Br under the Y. So now I've made a compound and I have to check my charges. So I'm going to go to the periodic table, and on the periodic table, one of the things on the periodic table that you were supposed to write down at some point, way like it feels like a million years ago, was like that silver always has a charge of +1. So I know that silver is going to be a +1, and chlorine is in column 17, so it has a -1. So when I crisscross those charges down, I get Ag1Cl1, right? And so I will check my ratio, and my ratio here is 1 to 1. So I can't really simplify that any further. So I'm just going to leave it as AgCl. Now I have this single element bromine by itself, and I'm going to go back up to the list of diatomic molecules up here again, and I'm going to see if bromine is there. And there it is. There's bromine. So that means that bromine has to have a 2 behind it. So now all that's left to do here is balance. And when I go to do that, I have chlorine, and I have silver, and I have bromine. So on my reactant side, there's 2 chlorines, 1 silver, 1 bromine. On the product side, there's 1 silver, 1 chlorine, and 2 bromines. So I'm going to start balancing from left to right. My chlorines are not balanced, so I'm going to put a coefficient of 2 here, which will give me 2 silvers and 2 chlorines. My silvers are not balanced now, so I'm going to put a coefficient of 2 here, which will give me 2 silvers and 2 bromines. And it looks like that balances out pretty nicely then. So then moving on to my next problem here, I have Na3PO4 and KCl. This I see as having 2 compounds. So this is going to tell me that I have a double replacement reaction. And in my double replacement reactions, I have something like a B. My template is Bx plus Ay will react to form By and Ax. Oops, wrong color. So I'm just going to match these things up. So under the B, I have sodium. So I'm just going to bring the sodium over here. Under the Y, I have Cl. So I'm going to put the sodium there. Note, I did not bring that 3 across because I have to check my charges. Under the A, I have potassium. So I'm just going to put a potassium here. And under the X, I have the polyatomic ion PO4. So now what I need to do is check my charges for both the sodium, the NaCl, and the potassium. So what I'm going to do is I'm going to do the NaCl first. So here I have Na with a charge of +1, Cl with a charge of -1. Crisscross those charges down, and I get Na1Cl1. So my ratio is 1 to 1. And that cannot be simplified, so I'm going to leave NaCl as NaCl. Now I'm going to look at potassium, the relationship between potassium and the polyatomic ion phosphate. So here I have potassium, which I know is a +1 from the periodic table. And from the back of my periodic table, I have phosphate, which has a charge of -3. So I have PO4 -3. I crisscross those charges down, and I get K 3 PO4 1. Okay, so now I'm going to check my ratio here, which is 3 to 1. And I can't simplify that either, but I do need to have a 3 behind the potassium in my formula. And so that's where the checking of the charges and crossing down is really important. So now to balance this one, I need to find some more room, I guess. So I'm going to do this, I guess, off to the side. I have, let's see, Na, and I have PO4, and I have K, and I have Cl. Oops, I don't know what that is, Cl. So I have, on the reactant side, 3 NAs, 1 unit of PO4, 1 K, and 1 Cl. On the product side, I have, I guess I'll put that up there. I have 1 Na, 1 Cl, 3 Ks, and 1 PO4. So to start balancing this one, I'm going to balance my sodiums first. So I'm going to put a coefficient of 3 here, which will give me 3 sodiums and 3 chlorines. My sodiums are balanced. My phosphates are balanced. My chlorines are not. So I'm going to put a coefficient of 3 here, which gives me 3 potassiums and 3 chlorines. And then this one is balanced like so. In the next reaction, I see that I have 2 elements, calcium and sulfur. So that tells me this is going to be a synthesis reaction, which means we're simply going to combine the elements. A plus Y will make AY as one product. So in this instance here, I'm going to take the Ca, put it under the A, take the S, put it under the Y, and now because I made a compound, I need to check my charges. So I have Ca, which is 2 plus from the periodic table, and sulfur, which is 2 minus from the periodic table. I crisscross those charges. Ca2S2 is what I get. So I check my ratio, right? And my ratio is 2 to 2, which can be simplified to 1 to 1. So in my product, CAS, I'm going to leave as CAS. So I still need to balance this particular one. So when I go to balance this one, oh, look at that. I don't have to do much. I have 1 calcium on the left side, one calcium on the right side, 1 sulfur on the left side, 1 sulfur on the right side. So I'm not even going to do the little tree thing. I'm just going to leave it like that. All right, our last one. We have lithium as an element, and we have Al2SO43 as a compound. So that's my hint giveaway here that this is a different type of single replacement reaction. Again, we're going to talk about what type of element is present. So in this case here, I have lithium, which is a metal, and so that's going to replace aluminum, which is also a metal. So in this one, I'm going to have a metal try to replace another metal in a compound. Okay, so on the product side, I will have B reacting with Y to have A left over. So in this instance here, I have B plus AY makes BY plus A. So I'm going to line my things up. So lithium goes under the B. The polyatomic ion SO4 goes under the Y, and then the aluminum goes under the A. And so now I'm going to check my charges. So lithium, I know, has a +1 charge. SO4, I know, has a -2 charge. And when I crisscross those charges down, I get Li2SO4 1. So when I check my ratio with that, it's 2 to 1, which I need to show that over here. I can't simplify that anymore, so it becomes Li2SO4. Now I need to look at my Al. It's all by itself, and when I come up to this diatomic elements list up here, I don't see Al anywhere, so I'm just going to leave it as it is. It doesn't get a number behind it. So now the last thing I have to do is balance this. So I have Li, I have Al, and I have the polyatomic ion SO4. On the reactant side, I've got 1 lithium, 2 aluminums, and 3 sulfates. And on the product side, I have 2 lithiums, 1 sulfate, and 1 aluminum. So in an effort to try to balance this, I noticed that my lithiums are not balanced. So I want to deal with those first, but I kind of see that like my sulfates are going to really kind of be driving this one. So I'm going to skip ahead and I'm going to put a coefficient of 3 here. That'll give me 3 sulfates and it'll give me 6 lithiums. And then I'm going to want to have 6 lithium, so I'm going to put a 6 over there, so that gives me 6 lithiums. And I have 2 aluminums, so I'm going to put a 2 here, so that gives me 2 aluminums, and then everyone's balanced. So it's kind of messy what we got going on here, but these are the answers to the practice quiz for the predicting products. Now, the second part of this quiz is determining whether or not a single replacement reaction will occur. And so, again, we have to be really aware of what's replacing what. So in this case here, I see that I have a metal, which is magnesium, and it's going to try to replace another metal, which in this case is hydrogen. Now, I know it's weird because we know that hydrogen is a nonmetal, but if you look at the activity series over here, hydrogen is on the metal side, okay? And if hydrogen is on the metal side, then we're going to be okay with trying to decide what happens here. In this case, magnesium is above hydrogen on this list, which means magnesium can replace hydrogen. So on my product side, I would have something like By and A all by itself. So I have magnesium and chlorine, and I have H all by itself. Now, a couple of things. I should check my charges. Magnesium has a charge of +2. Chlorine has a charge of -1. I crisscross those charges down, and I get Mg1Cl2. So I'm going to check my ratio, and my ratio is 1:2. So I can't really simplify that. But I do need to have a 2 behind chlorine here. So that's going to go there. I'm going to go way back up to the top of this worksheet here and note and try to figure out if hydrogen is part of this list. And definitely hydrogen is part of this list. So that means it's going to be an H2. It needs to be an H2 over here. So I'm going to put a coefficient of 2 there. If we were to balance this particular reaction, let's see, we have 2 hydrogens on the product side and 2 chlorines on the product side. So this one really ends up balancing kind of simply by putting a coefficient of 2 there. But the other part of this situation is we have to explain how we knew the reaction was going to occur. And in this case, our reasoning could be the reaction occurs because magnesium is more reactive than hydrogen, so the reaction occurs. So I could put the reaction occurs because magnesium is more reactive than hydrogen. All right. In the case of Ag and AlPO4, I have a metal here in Ag. I have a metal in Ag, and so that means it's going to try to replace aluminum. So I'm going to try to figure out what's going on here. So This would be my B and my AY. So silver, way down here. Aluminum is, where's aluminum? Right here. And because silver is below aluminum, it cannot replace aluminum. So this is going to be no reaction. And it's no reaction because silver is less reactive than aluminum. Okay. The last one here we're going to be looking at is another single replacement reaction, but we have to be aware of what's trying to replace what. Here I have a nonmetal chlorine, so the nonmetal is going to try to replace the nonmetal. So this one would be actually looking like this. And on my product side, I would have AX and Y by itself. So in this case, let's check and see if this reaction can happen. So here I have the element chlorine, the nonmetal element chlorine, and we're comparing it to the reactivity of the nonmetal bromine. And because chlorine is above bromine on this one, chlorine can replace bromine. So on this side, I would have Na and Cl, and I would have bromine by itself. I'm going to check my charges. Na is a +1, Cl is a -1. Crisscross the charges down. I get Na1Cl1. Check my ratio is 1:1. I cannot simplify that, so NaCl works. Br, though, is all by itself. So I'm going to go back up and I'm going to check to see if Br is in this list. And sure enough, there's Br in that list, which means that bromine needs to have a 2 behind it. So if we're going to balance this one, as long as we're doing it, I would have Cl, Na, and Br. I have 2 Cls, 1 Na, 1 Br. I have 1 Na, 1 Cl, and 2 Brs. So I'm going to start by trying to balance my chlorines. So I'm going to put a coefficient of 2 here, which gives me 2 chlorines and 2 sodiums. So I'm going to put a coefficient of 2 here, which gives me 2 sodiums and 2 bromines. So it's balanced. Now, the last thing we need to do is explain why this reaction occurs. And so we can say that the reaction occurs because chlorine is more reactive than bromine. Than bromine. And so there you have it. That's how your quiz is going to look tomorrow. So hopefully this helps explain a couple of things, and hopefully you feel a little bit more confident about your quiz. If you have any questions, please do not hesitate to ask, and good luck on your quiz tomorrow.